Okay, today we are reviewing our rules for logarithms. Okay, so basically the way a logarithm works is it is the reverse of an exponential form. In other words, we can actually rewrite exponential form in logarithmic form, or we can convert from logarithmic form to exponential form. So when I have 3 to the fourth power equals 81, 3 is our base, 4 is our exponent, and 81 is our answer, or our value. So when I'm looking at the logarithm, I'm saying 3 to what power would be 81? And 3 to the fourth power would be 81. If we look over at our power chart, I can look at 3 and say, well, 3 to what power would be 81? Okay, so I follow my 3 line across. And 3 to the fourth is 81. Okay, so when I'm working out logarithms, or changing from exponential form to a logarithmic form, I'm going to say, well, my base is 7. My power is 2. And my actual value is 49. So to write this in logarithmic form, I would say log base 7 of 49 would equal what? Well, what 7 to what power would equal 49? The second power. Okay, so for number 2, if I have 6 as my base, 3 is my power, and 216 as my solution, I would say log base 6 of 216. Now, 6 to what power would equal 216? That would be the third power. Okay, number 3. I've got 2 to the fifth equals 32. My base is equal to 2. My power is equal to 5. And that should be my x. I'm trying to watch the camera and film and write at the same time. And then my value is 32. Okay, that means that log base 2 of 32, well, 2 to what power would equal 32? That would be the fifth power. Now, for these other examples, I'm switching over to exponential form. So 9 is our base, 3 is our power, and our answer is 729. So I would say 9 to the third power equals 729. And we can check that and see, let's see, on our power chart, 9 to the third power. This is the first, the second, the third. Oh, and it is 729. Okay, so 2 to the sixth power would equal 64. So 2 to the sixth equals 64. And they didn't put a number here for the base. So, in this case, when we don't have a number here, we understand that there's going to be a 10 for that base. So 10 to the third power equals 1,000. And the way we should know that, got ahead of myself again. I apologize. Okay, b equals 10. And again, that's understood that when there's not a number there, it's base 10. X equals 3. And the answer, A, equals 1,000. So, 10 to the third equals 1,000. Okay, let's flip it over to the back now. And we have some problems where it asks us to use some math, mental math, to actually solve this. We do have our power table that we can refer to. Okay, so 2 to what power would equal 64? So I'm going to go over to my power table. 2 going across to the 6th power equals 64. So this would be 6. Okay, 4 to what power would equal 64? So I'm going to look at 4. 4 to what power would equal 64? And it's going to be the 3rd power. So my answer is 3. 6 to what power would be 1,296? So on number 9, or 6, sorry, 6 to what power would be 1,296? And that would be the 4th power. Okay, let's do this next row. 10 to what power would equal 100? Well, we know that since there's not a number there, there's a 10, so that would be the 2nd power. 10 to what power would equal 1? Well, let's see. That would be the 0th power. Because, again, on our power chart, any number to the 0th power is 1. Okay, so 10 to the 0th power would equal 1. 10 to what power would be 10? And that would be 1st. Okay? 100 to what power would equal 10,000? That one would be the 2nd. So 100 squared. 9 to what power would equal 81? Well, 9 squared is 81, so it'd be the 2nd power. And 5 to what power would equal 25? And that would be the 2nd power. So, Chloe, I want you to do this. And then, once you've done this first worksheet and have it completed, this is the Logarithms A worksheet, then send it to me. I'll give you credit, and we'll upload from there. Thank you so much.